All right, Chapter 10 lists, we are back at it. I'm going to start with a very quick review of where we ended last time. Here were some common operators for a list, for a sequence. We could check if a value was in a list or not in a list. We could concatenate two lists. We showed how to make multiple copies of that same list, how to look for an element in that list using its index, list slicing, and then to get the length or the min or the max or even the sum of a list. And we also use the for loop to iterate over the list. We're going to revisit some of these things, but this is where we ended, and we also ended looking at an example of what I just covered. And what I really like to focus on, though, is even though we covered this, it's worth talking about it again. This index operator. Yes, we've seen that with strings. Yes, we should be pretty comfortable with it, but it's definitely worth revisiting. So how do we access the individual elements of our list? We use this index operator, this pair of square brackets that you see here. So the syntax is, given your list, in this case called my list, you have those square brackets, and then you use the index to reference the value that you're trying to access. Remembering that lists are zero-based, meaning the first index is 0, and the last index is the length of your list minus 1. So if we have 5 elements in the list, the first index is 0, the last is going to be 4. 0, 1, 2, 3, 4. That's a total of 5. If we have 10 elements in the list, the first index is 0, the last is 9. And finally, if you had 47 elements in your list, the first index is 0, the last is 46. So here we have this list. It has 10 values. The list is called my list. And for example, my list at index 0 is a 5.6. My list at index, let's just count some, 0, 1, 2, 3. My list at index 3 should be 13.2, and indeed it is. And finally, if you counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, my list at index 9 should be 1, 1, 1, 2, 3, and again, indeed it is. What is actually saved in these individual indices of the list are the values, right? As I just depicted. Now, what's actually saved inside the variable my list? It's actually an address. No need to overcomplicate this right now. But what's actually saved inside my list is an address to where this entire list can be found in memory. So my list does not store these numbers. My list, this variable my list, it stores an address that then points over in memory to where the actual list is found. A graphical depiction is really what you already have on the slides, but I'll just draw this out here. So if we have my list, and my list, I usually depict an address with an asterisk. Well, what is stored in that variable my list is an address which points over in memory to what? To the actual list of those 10 elements, where we started at index 0 and we ended at index 9. That's actually what's going on in memory. And so when we have our list variable followed by this brackets, and inside those pair of brackets we have an index, we can use that just like we use a regular variable. It's known as an indexed variable. So consider this line of code here. This is an assignment. We go to the right of the assignment statement. This says take what is inside index 0, add to that the value at index 1, and then take that resulting sum and save it back inside the value, save it back inside the location at index 2. Here's another example. We'll go through this one, but first let me come over here to Thani and let's type in list1 equals 1, 2, 3. Just for kicks, print list1 so we can see how this prints. We get 1, 2, 3. Now what if I did that exact line of code we just saw? If I said list2 equals, we said list 0 plus with list 1. So let me just call this pardon me, I'm just going to call this x to make it easy, which is a horrible name. So I'm going to say x at index 2 equals x at index 0 plus x at index 1, right? Okay, so here, now, afterwards, when I print x, what am I going to get? So we're taking the value at index 0, which is a 1. We're adding to that the value at index 1, which is a 2, just so we don't, I'm going to even change this to 4, 5, and 6. We're going to take the value at index 0, which is a 4. We're going to add to that the value at index 1, which is a 5. 4 plus 5, that's 9. And we're going to take that 9 and save it into index 2. So we're going to overwrite that 6 with a 9, and here's what we get. We had 4, 5, 6. Now we have 4, 5, 9. So just a reminder of what we've seen previously. We've also seen how we can loop over our list. If I made this 4, 5, 6, 7, 8, and I wanted to loop over this list, we saw this with strings. I also showed this on the last video. If I were to say for I'll call this for num in x, print num, this will loop over all values of that list, and we individually get them, we save them into this variable num, and then I can do something with that, such as printing it. I could have called this Bob, right? It doesn't matter, it's just a variable, and we get the same output, 4, 5, 9, 7, 8, because again, we updated that value at index 2. We also showed you that instead of looping this way, you could loop over the traditional loop. You could say for I in range, but the range function needs a value inside there. So how many times do we want to loop? Well, we can see here, I want to loop 5 times. So for I in range 5, we would say print x at some index. What index do you want to print x at? Well, we want to print x at index 0. Then we want to print x at index 1, the 5. Then we want to print an x at index 2, which is the 6. Then x at index 3, which is the 7. And finally, we want to print x at index 4, which is the 8. So we can use this I variable because I loops from 0 to 4. So I can say print x at index I. Let me type this. Other method of printing. And when I show you these two outputs, you're going to see they look identical. We have 4, 5, 9, 7, 8, 4, 5, 9, 7, 8. Identical. Finally, it's important to know we wouldn't want to put 5 here because we want the code to be more general. So it's more appropriate to really say length of x, which is the length of the actual list, which is 5, but now the code's more general and you get, again, the exact same output. So this was, again, a lot of just reminders of what we saw last time. 2 cautions. Common mistakes for new programmers are to try to reference a list outside of its given range. For example, if I were to, right here, if I were to say print x at index 3, how about index 3? Yeah, x at index 3 is, and I'm just going to use concatenation to print this. I'll use a comma, old school way. No, it hurts I'm not going to do that. It hurts my heart to do that. X at index 3 dot format, x at index 3. There we go, right? This should print just fine. Let's run this to see the code, or see the result. X at index 3 is 7. That's what we expect. What if I now try to print index 4? That should also work. X at index 4 is, and again, y'all should be coding this with me, not just watching. X at index 4 is 8. Okay, that's what I expect. Finally, what if I tried to print x at index 5? What's going to happen? This will give me an error. List index out of range. There is no index 5. It's just 0, 1, 2, 3, 4. There is no index 5. That is a common mistake. So always remember, you never go past the length of the list minus 1. The length of the list here is 5. 5 minus 1 is 4. 4 is your rightmost bound on that list. Your list is length 80. Never go past index 79. Another common error is an off by 1 error. And this happens because new programmers forget that the first index of a list is index 0. And when we forget that, we're going to be off by 1, because if we have a list of size 20 and we're trying to loop from index 1 to 20, well, we're going to be off by 1, and when we try to print at what's in index 20, a disaster, and it's going to be an error, list out of range. So remember that we always start at index 0. And here, for example, what if the list was length 20? What is this loop saying? This loop says, hey, keep looping as long as I is less than or equal to 20, and then print my list at index I. Well, this is going to loop 21 times. And we're going to be printing my list at 0, my list at 1, my list at 2, all the way to my list of 17, my list of 18, my list of 19. But it's even going to print my list at index 20, which would be wrong, and we would get an error. So here you can fix that by replacing the less than equals with a less than to address that. We've already seen negative indices. This is just a reminder. We've seen this with strings. We can use negative indices on a list. List of -1 brings you all the way to this right side. So I could refer to this 21 by saying 0, 1, 2, 3, 4, 5. I could print index 5, or I could print index -1. In the same way here, I could print index 4 this way, or I could say x at index 4 is really x of -1, which is cool to be able to do it this way in Python, because normally if you want to print that last value in the list, you have to do this, which is fine, but check this out. We'd have to say x at index 4 is, we'd have to say in here, which index do I put here? Which index? I would type length of x, which is 5, -1, and that will give us 4. So it's more of a calculation, whereas here I can just say -1 and go all the way to that rightmost value. If I said -2, let me change this just to a -2 briefly, this will print the 7. We see the 7 gets printed now because it's -2. This is index 3. So we see the 7 gets printed, okay? So we can use negative indices, which is super cool. Here's our first program. Write a program that will generate 1,000 random integers, each between 0 and 9 inclusive, and we want to count how many random numbers were created of each of those integers. How many random 3s, how many random 5s, how many random 6s, how many random 7s, and so on. So how would we do this? I already gave you a hint right there. But let's skip ahead. Problem solving phase. We need to use random, right? I said we want to generate 1,000 random numbers. So we need to do a loop. Each iteration of the loop, we need to generate a new number between 0 and 9 inclusive. And we need to somehow keep track of how many zeros we made, how many 1s we made, how many 7, 8, 9s we made, and keep a count of all of that, and then print it after the fact. So let's go over and start this program. So here, let me cut this out. Let me make a new program, save, and let's just call this here list stuff. Paste this in here. All right. Come back to this. Program 3 is what I called it. Program 3 count random. So first of all, import random. And you know what? Just so we're going to have the same output, let's go ahead and set the seed. So random.seed, and let's set it to what? Count program. Let's call it what? Let's call it count program. Okay, and what do we want to do? We need to loop 1,000 times. Let's go ahead and make a main so we can do this properly. And in here, we need to loop 1,000 times. Therefore, if you know how many times, you need to use what kind of loop? A for loop. So for I in range, 1,000. What do we want to do at every iteration of the loop? Generate a number between 0 and 9 inclusive. So I'm going to say num equals random.randent 0, 9. Easy. Now, what do we need to do? We need to see or check what value, I'm gonna say it first, then we'll make a comment. Check what was saved, or check what number was generated, and increment a count that will keep track of how many. So if we generated a 5, increment a variable called count 5 to count how many 5s were created. So how would you do that? Well, the cheesy way would be up here, make all kinds of silly variables and initialize them to 0. So I could say count 1. Count 1s equals 0. Count 2s equals 0. Count 3s equals 0, and so on. We have to do this all the way up to count 9s, right? This would be count 8s, and this would be count 9s. We have to go all the way up 10 times. I skipped 4, 5, 6, 7, right? So we have to do all of those, and actually I skipped count 0s, so we have to start with count 0s. Count 0s, right? So this is what we're doing. We have to make all these variables. And now we have to do what? Check what number was generated and increment the appropriate count. So I would say if num is 0, count zeros plus equals 1. Elif num is 1, count 1s plus equals 1. Elif num equals 2, count 2s plus equals 1. And so on. I hope that's clear what's going on, right? We'd have to keep doing this all the way to, this would be count 3s, 4s, 5, 6, 7, 8. So this would have been else if num equals 8, count 8s plus equals 1. Finally, I don't need to do elif num equals 9. I don't need to do an elif here. I can only, in fact, if I want, just do else. And here I could say count 9s. Why could I do an else there? Why? Think about that. Because we generated a number from 0 to 9. So if we've already checked, is it 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9? If we've already checked all of that, if it's 7 or 8, well, the only other option is 9, so increment count 9s. Then, after we're done with this loop of 1,000 times, we need to do what? We want to display the counts. So I'll write one of those. I don't want to write all of them. So this would be 10 individual print statements. I'd say the count of zeros, or the number of zeros generated was dot format count zeros. So this would be a solution. I want to make sure this is very clear. This would be a solution. We have to print the count 1s, and I'll end with we have to do the 9s right here. We would have done count 0s, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, and 9s, and we have to make these 10 individual print statements. This would be a solution. Horrible solution. Nothing wrong. Think about it. That's the solution you should think about as a newbie. Absolutely. But horrible solution once you know what to do. So what would be a better way to make this happen using lists? The whole idea is what we're studying is lists right now, right? So what we want to do is make a list of size 10. So remember, we showed that we could make I'm going to call this list counts. We can make a list, an empty list like that, right? How do I make it size 10? Well, I can multiply it times 10, but I need to give that list an initial value. So if I do this, if I say make a list with one element of size 0, one element, and that one element is 0, and then multiply this times 10, the result is I have a list of size 10 of all zeros, which is perfect. Because now, what is stored at index 7, for example, it will be the answer. It will represent the count or the number of 7s that were generated. So check this out. Generate a number between 0 and 9. Check what number was generated and increment the appropriate index. So even though we're on the right track, here's another cheesy way to do this. If we didn't think about how, we'd have to once again say, okay, well, if number equals 0, do what? We're going to say counts at index 0 plus equals 1. Elif num equal 1, counts at index 1 plus equal 1. Elif num equal 2, I'll do this last one. Elif num equal 2, counts at index 2 plus equal 1, and so on. But we don't have to do that. Pause the video. See if you can think about why we don't have to do it that way and what else would work. So what we can do is actually the following. We don't need any of those if statements. Instead, I want to say, you know what, if I generate a 7, let's increment index 7. Let's increment index 7 if I generate a 7. If I generate a 4, increment index 4. If I generate a 0, increment index 0. If I generate a 9, increment index 9. Well, the number that's being generated is actually saved inside this variable num. So check that out. We're saying generate a 4 and then go to counts at index 4 and increment it. If you generate another 4, go to counts at index 4, increment it. You generate a 9, go to the counts at index 9, increment it. So when we're done, I'm just going to print counts like this briefly. And let's see what happens. These are those counts. The number of zeros is 107, the number of ones 97, number of twos 98, number of threes 88, and so on. Of course, if I run it multiple times, we're going to get the exact same output, the exact same result. Why? Because I have this random seed. If I comment that, here we get different numbers each time. And you can see they're all close to approximately 100, because if your random generator is evenly distributed, right, you should get an even distribution of those numbers. So approximately 100 zeros, approximately, that's a little bit lower, 100 ones, and so on. So let me come ahead and delete this, and let's have this here again for our random seed, and we now run it, and this is the result. Hopefully you have that same result. Only thing I like to do here is I like to go ahead and loop over this 10 times, the length of count. So 4, let me loop here, 4, I in range, and I could just loop 10, and I'll change that, you should not though. I want to actually just print a nice statement, okay, instead of just printing this list as we see here. So I want to type here, print the number of blanks generated was blank. Dot format, the number of I, comma, and this is going to be counts at index I. Here we're saying the number of blanks generated. Well, we want to say the number of zeros generated. The number, let me go and run it, and then I'll go through the explanation. So the number of zeros generated, right? We want to say the number of zeros generated was 107. The number of ones generated was 97. The number of twos generated was 98. So here, this value that comes right here is just this I value, going from 0 up to 9 inclusive. So 0 up to 10, but not including 10. The number of twos generated was, and what do we want to print here? We want to print counts at index I. So if I say the number of sevens generated, when I is 7, the number of I's, I is 7, generated was, what do we print here? Counts at index 7, and this is our result. Great problem. Here is a solution in the slides. I didn't do that nicer printing, but it is all right. List slicing. We've already seen this with strings as well. So this will be something that hopefully is okay for us. Given a list, if we want to get just a portion of that list, we can use list slicing. So I'm going to come over here to this other list program we had open. Let's delete all of this. And let's say if I were to say y equals x, let me change this from x and y. Let's call this now list 1, and let's say list 2 equals list 1 from index, let's say 0 to 3. What happens now if we print list 2? List 2 is going to be 4, 5, and 6. Well, what happened? What did we do with this, if you recall from strings? This says take list 1 and give me just a slice, a portion of list 1. Which portion? Well, the portion that goes from index 0 to 1 to 2, but not counting 3. So we do not include the 7. So 4, 5, and 6. If I had said let's go from 2 to 3, what would that be? It'd say here's 0, here's 1. So start at 2 and go up to 3, but not including 3. So really, this will give us just the 6. What if we said, how about we go from 2 to 5? What's that going to give us? From 2 to 3, 0, 1, 2. From 2 to 3 to 4, but not to index 5. There is no index 5, and that will give us 6, 7, and 8. Of course, if I said from 2 to 6, we would now be going out of bounds, but it doesn't actually give you an error here. It just gives you that maximum right side of that slice. So this is list slicing. There's also some things we haven't seen with list slicing. The fact that we can omit either that starting or that ending index. So for example, if I come here, let's make this 2 to, let's make it from 1 to 4. 1 to 4 would be 1, 2, 3, and we would exclude the 8. So that would give us 5, 6, and 7, right? What if I said from 0 to 4? Of course, that would give us 4, 5, 6, 7. Well, check this out. What if I don't even put a 0? If I leave this part blank, that effectively says start from the beginning, and you still get 4, 5, 6, 7. If you see I run it, you get the same answer. Or what if I've had this as 1, and over here I leave this as blank? That says go from 1 all the way to the end, and that will give you 5, 6, 7, 8. And you don't need to put a space here. I'm just leaving a space so you can see it's visually left blank. I could have just had from 1, colon, it'll go from index 1 all the way until the end. So as we see here, if you put nothing on the left, it's really the same as putting 0. If you put nothing on the right, it's the same as going all the way to the length of your list. You can do list slicing with negative indices. What if I said go from 1 to -3? That's fun. Let's go from 1 to -1 or -2. Remember, 1 is right here. Where's -2? Well, this is -1. This is -2. So the 7 is -2. So if I say go from 1 to -2, but not including -2, that will be just the 5 and the 6. Okay? So this is just good to go over this, understand the list slicing and how that works. We've already seen this, so I can go quickly on these couple of slides. Concatenation and the repetition operator. We've seen what concatenation does. Given two lists, we can concatenate them into list 3. Here's the resulting list. List 4, if I said take 3 times list 1 is just this list of size 2 with the values 2 and 3 inside it. If I multiply that times 3, I'm going to get 3 repeats of that exact same list. 2, 3, 2, 3, 2, 3. Or like what we did on that program, here is I said make a list with only a 0 and repeat it 10 times. If we look at this one up here, how about if I say list 3 equals list 1 times 2. And now print list 3. What are we going to get? We're going to get 4, 5, 6, 7, 8, 4, 5, 6, 7, 8 as one new list. We've seen the in and the not in. It just tells you true or false is a given value in the list. To in list 1 is true. To not in list 1 is false. We've seen how to traverse. So this is nice. All of this is really repeating what we've already seen. How can we traverse our list? Just say for something in my list and we print that something. So if I delete this, if I just want to print that list one element at a time, I would say for X in list 1. I could choose something different than X. For Bob in list 1, print Bob. We're literally taking every value out of the list, saving it into this variable Bob, and then printing Bob, and this is what we get. Now compare and contrast to that to the other type of for loop we can use to iterate over our lists, where I'm going to use the range function. For I in range, length of list 1. So I'm going to loop here. What's the length of list 1? It's 5 times. For I in range, this is really just saying right here, 5, but it's better to be more general and code it this way. What do I want to print? A mistake is when students say, oh, print I. And they think they're going to print the list. Well, if you print I, what are you really printing here? You're just printing the indices. Let me come here and type print other method of printing, and we covered this earlier, as you likely remember from this statement that I just typed, the other method of printing. And what are we printing here? We're not printing the values. And you're like, well, why did it print 0, 1, 2, 3, 4? You want it to print 4, 5, 6, 7, 8. This for loop is super easy to understand. This one's not hard to understand, but you have to just pay attention to what's going on. Here, we're saying for I in range 5, right? As I said, this is effectively 5. Well, what values will I get? I is going to get the values 0, 1, 2, 3, 4, which is what got printed. So how can we use that to print our list? Well, instead of printing 0, we want to print what? We want to print, I want to print list 1 at index 0, then list 1 at index 1, then list 1 at index 2, then index 3, and then index 4. So index I, because I goes from 0 to 4, and now we get the exact same output. So we've seen both of those, how you can traverse the list in both of those fashions. Comparing lists. We can compare lists using those operators, but it only works if we have the exact same type of elements. What's going to happen is the first elements of the two lists will be compared, the next element will be compared, and so on until there is something different, and then the elements will be compared, and the one that is smaller, that will be returned. So for example, if we have list 1 and list 2 as shown, does list 1 equal list 2? Of course, you can see they're not equal. Are they not equal? That prints true. What about list 1 less than list 2? So list 1 less than list 2. So it starts by Python first looks at index 0 of list 1 and index 0 of list 2, and it compares the word green to red. Well, remember, what is a string? It's really a list of characters. So when comparing this string to this string, Python's going to look at each character. It's going to say, well, look at the character at index 0 of this string, the G. Look at the character at index 0 of this string, the R, and compare them. And in fact, they are different. Obviously, G is different from R. And the G is smaller. Therefore, this is true. Is list 1 greater than list 2? That's false. And so just how we can compare lists. List comprehension. This is, I'm looking at the time, we're at 33 minutes, perfect timing. List comprehension, super, super, super important. What are list comprehensions? In short, it's a really cool way of making lists in Python. And we make this list with an expression that's followed by a for clause and sometimes even additional if statement. It's going to be super funky when you first see it, but it's really cool how it works. I say here a heads up, super important. We will be using this and having many questions on it. So let me just come over here into our list stuff. Let me delete all of this. Let's make a new list. And what did I do here? I said for x in range. So fine, list 2 equals, here's an empty list, right? So check this out. I can say x for x in range 5. What did I just do? Well, that's going to be a list. Let's print these. This is going to be a list with the values 0 through 4. Because what we did, or what Python's doing, is it's looping. You know what this loop is. For x in range 5, x will get every value from 0 to 4. That's what this for loop does, right? X will get every value from 0 to 4. This is not a surprise. I think everyone should be fine. If I did this and I said print x, you should get 0, 1, 2, 3, 4, right? Let me even delete this. That should not be a surprise. We know how to do that. So now, if I say list1 equals x for x in range 5, well, what does this do right here? We just saw it loops from 0 to 4. And what this list comprehension is saying, it says loop from 0 to 4. Each time, take one of those values, save it into x, but instead of printing x, we want to take this x right here, and we want to put it in a list. And this is the result. We print list 1. And when we print this, we get 0, 1, 2, 3, 4. Super cool list comprehension. What else can you do with this list comprehension? I could say list2 equals, what if I want to generate all numbers from, I don't know why, but let's say I wanted to generate numbers from 1 to 10, including 10, but I want half of those values. What I mean by this is, check this out. If I said x for x in range 1, comma 11, because I want to go up to 10, and I'm going to do a step size of 1. What is this going to do if I just print list2? This will print for me just the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now, what if I did this? What just happened here? This says loop from 1 to 10, including 10, right? Not the 11, 1 to 10, including 10. So we're going to loop and we're going to get 1. 1 gets saved inside x. And what do we do with that x? We're not going to print it. We're going to put x in the list, but first we're going to multiply it times 0.5. Then we're going to take the 2, which is the next x in this range. Take the 2, save it into x, multiply that times 0.5. Then take the 3, save that to x, multiply that times 0.5. And when you run this, look at the result. Now we have this list. Very cool how list comprehension works. Or let's do another one. Let's say, if I wanted to say list 3 equals, let's make a new list all of a sudden, x for x in range, and let's just make a big list of size, oh my gosh, 20. Let's print list 3. And here's our value, here's our resulting list. What if I only want to include the numbers that are even? How could I do that? Check this out. I could say x for x in list 2 if what? I could put an if statement right here. If x mod 2 equals 0. So this is going to say, give me all numbers between 0 and 19 inclusive if they're even. And this is the result. Funky. Super funky. But lists are amazingly helpful, so we can understand we would love to have quick, succinct, short ways of creating a list. That's list comprehensions. Now, once you have a list, and we're going to cover more list comprehensions, but once you have a list, Python gives you all kinds of very helpful methods that allow you to manipulate the list. We can append elements to our list, which means add an element at the end of the list. We can count the number of times that a given value appears in our list, which is super helpful. Let's come over here and let's get at that code that we did for generating a random number. It's really just this, and we're incrementing counts, right? So what if I wanted to, let's do this. Let's take all of this right here. I'm going to take the whole main, just completely plagiarizing my own code. And I don't want the counts. I'll call it counts. I'm going to delete some of the comments here. I just want to make a new list of size 10. I'm going to call this list 1. And I want to just loop. Let's see how many times I want to loop. I want to make a new list of size 10 of randomly generated values. That's what I like to do. So I may not end up using much of this code. I want to make a new list. Let's just erase all of that. Make a new list of size 10 of randomly generated generated values between 0 and 9. So let's actually make a list of size 100 of randomly generated values between 0 and 9. So how could I do that? Well, one way I could make an empty list, and then I could loop 100 times. So for I in range 100, and at each time generate a new number. So I need to have my random. Random.seed. I'll call this Python as the seed. I generate a new random, so num equals random.randint 0, 9. And now what do? I could say list1.append num. Append adds that element to the end of our lists. And so now when I'm done with that loop, I can just print list1 and look at what we get. We're going to get this huge list with all these numbers. Remember, I generated 100 different numbers, and I appended each one to our list. Append means that I add it at the end. So the first number generated was a 6, then a 2, then a 6, then a 0, then a 4, then a 1, then an 8, and so on. Now, what about afterwards? If I just want to count, hey, how many 5s are in that list? What could I do? Well, Python says right here, using this count method, you can literally just type list1.count and then put the value that you're looking for. And what Python will do is it will loop over that list, and here it counted up the number of 5s. There's 9 5s apparently. Python will loop over this list and will count the number of 5s. That's cool. I could have made my own function to do that. I didn't need to use Python's count method. I could have said define my count function. I cannot spell or type. My count function. And this my count function, I'm going to send over my list. And what do I want to do? I'm going to call this count equals 0. I'm going to loop over the entire list for I or for val in list1. If val equals 5, count plus equals 1, and then return count. Quick and dirty, I made a count function. So here, I could print, I called this my count function, print my count function, and I send over list1. Not the greatest looking function, but it works. And here, what happens? It counts, and we also get 9. So I could have made my own function to count, loop over the whole list, count how many 5s. If it finds a 5, increment count. That would have worked, right? Or I just use the Python built-in count function instead of making my own. That's cool that they have that function or that method available to you. So I'm not going to go through all of these in detail and show examples. You should pause the video, read over them, look at the next slide, and see how these examples work. So I'm going to cover a few. Index, it returns the index of the first occurrence of X in the list. So where's the first occurrence of an 8? We can see 0, 1, 2, 3, 4, 5, 6 is the first occurrence of an 8. So if I wanted to print, the first 8 is found at and I'm going to say list1.index 8. It's going to look for the first 8 and it's going to print it. And what gets printed here? The first 8 is found at index 6, which is what we said, right? Insert inserts an element at a given index. Pop, what does pop do? Removes the element at a given position and then returns that to you. What does remove do? It removes the first element, not at a given position. It just removes the first element. So if I were to say just right here, list1.remove, and then print list1, what actually happens? So here, takes exactly one argument. Remove the first occurrence of element x. Okay, that was my mistake. Remove a 6, because we already had a 6. I want to remove the first occurrence of a 6. So check it out. Here's the list. Now if I say remove 6, what happens? It removes the very first occurrence of a 6, which was right here at the beginning. That 6 is gone. It's gone from the list. Reverse. Oh, that's nice. Reverse a list. Let's make this smaller instead of so large. Let's get rid of some of these other things here. What about after printing that list, if I want to print list1.reverse? What's going to happen here? And I think I know what's going to happen there. Yeah, it's going to print none because that's a function. So I need to print here list1, and I need to call the function, the method first, list1.reverse, and then we look at the list. And what do we get? It's literally the list now in reverse. Super cool, right? So we can reverse our list that simply. What about sorting? List1.sort. And now print list1. What do we get? It actually sorts our list for us, which is very, very helpful. So once more, read over these various methods, look at how they work, look at these examples, pause the video, make sure we understand what those examples are doing and how each of these methods work. The last thing we want to cover for this video is how to actually split up a string into a list, which is very helpful. So the string class contains a method called split. And it's just easier to, let me just show you an example and then we'll talk about what's actually going on. So here we have this string called items. And look at what I do in this line. I say items equals items dot split. And then what happens is I get this resulting list. And you know what? I'm going to pause. All right, through the power of pause, I just changed that variable. I don't like using the same variable here. So we had a string saved into this variable called items. And then I used that string and I said dot. And we've seen string methods before, right? Is digit, is alpha. So we take the string. Well, another method is called split. What that split method does is it will take a given string and try to separate it into its different parts, where each part visually is, you can see the separation with a space here. So the consequence is we can see that there's really 4 names, right? Each one separated by a space. And so we have Jane, John, Peter, Susan. Well, the consequence or the result of executing this dot split is I now get a list of those 4 names, which I've chosen to save inside list1. So here are those 4 names in a list as a result of this. Now, how did we split this? We split it based off of a space. And that space is what is known as a delimiter. The delimiter is what you're using to split the list by. And it doesn't have to be only a space. You could use a different delimiter. So I want to come here back to Thani. Let me open this up. Let's make just a list. List1 equals, and let's make a string. So some string, I'll just call it S. S equals A, B, C, D, E. And now if I say list1 equals, and we want to do this exact same code. So I'm going to say S dot split, and now let's print list1 and look at the result. We're going to get a new list of those values. Now, I did not put a space here as a parameter inside the split method, but I could have. This really says split it based off of spaces, and it worked. Well, what if there weren't spaces? What if instead of spaces I had commas? A, comma, B, comma, C, comma, D, comma, E, with no spaces. Well, now if I say split it based off of spaces, what's the result? I get a list with only one value. Remember, each value in the list has these quotation marks around it. So I really now have a list of just one value, and here's that value. A, comma, B, comma, C, comma, D, comma, E. That's one value. But what if I said split this string based off of commas? What's the consequence? Ooh, you see that? So you don't have to split just based off of a space. You can say, you know what, take this string, and anytime you see a comma, what came before then was a new value in the list. What if you put two commas back to back? Look what happens. You get here an empty string in the list. This is a list of strings. We have the string A, an empty string, the string B, the string C, the string D, and the string E. Very cool how that works. So we can use different delimiters, not just a space. I showed you a comma as a delimiter. What if you were given, and here's a practical application, what if you were given this date? The user enters a birth date or some date for some reason, and so we have here a date, and the date is 4/18/2023, today's date. And you want to get the individual components of this date. What could you do? Well, I could say, let's split it based off of a forward slash, and here's the result. So now I could say the year, or the entered year is dot format, and what am I going to print? I'm going to print index 2 of list 1. Because index 2, this is index 0, this is index 1, this is index 2. And we say the entered year is 2023. So we can see there's actual practical applications of splitting, and that's just one example. So the delimiter used here was a forward slash. Great example of splitting and using that delimiter. Often it's also very helpful to read in values from a user all on one line. And we could do that using a list, because normally if we wanted to ask the user, enter 10 numbers for I in range 10, list.append, and look at what I'm doing here. I'm saying eval input. We're really saying one number on each line, hit the number, hit enter, and we're going to append it to our list, right? Let's check that out. If I coded this and I said list 1 equals an empty list, and now we say print enter 10 numbers, should really code this up, and let's loop 10 times for I in range 10. We want to do what? We're going to say list 1 dot append. We're using the append method. And we're going to append what? We're going to append the number that we are reading from the user. Let's say I did it this way, in case we don't like it all done in one step. I could have first said read number from user. So num equals and input, and then list1 dot append. Print list1. Let's actually just do this 5 times, not 10 times. Let's run this. And let's make sure this is not 10 numbers, 5 numbers. Enter 5 numbers, 1, 5, 3, 2, 8. And here's the list, right? That should make sense without any additional explanation, because we know for loops, we've seen list1 dot append. But what's going on here is, so I made this empty list, I appended 5 times to it, here's the result. But what if you didn't want the user to enter one number per line? What if instead you wanted the user to do this? 1, 5, 3, 2, 8, and then hit enter. Well, what's going to happen is we're going to get an error. Why do we get an error? Because input, as you know, takes the entire string of text. It takes the entire string of text and then tries to convert it to an int, spaces and all, and that will absolutely give you an error. So what could we do? We're going to use the input function to read that entire line, but that's going to give us what? So check this out. Enter 5 numbers all on one line. So if I did this, input line equals, and let me put end equals right here. Input line equals input. I scan the entire line and I save it into input line. Now, how can I make a list out of that? Because right now, if I print input line, what am I going to have? if I just print input line, 1, 2, 3, 4, 5. Well, it literally just read all of that as a string and it saved it into this variable input line and it printed it. Okay, well, what else can we do? I'm going to say list1 equals input line dot split. And let's split it off of spaces. We'll explicitly type the space. Remember, if we don't put a space here, the default is it splits it on a space anyway. But sometimes you want to visually, see that there's a space there. So now let's print list1. And when we print list1 now, let's do 4, 7, 8, 1, 5. Well, check it out. Here is the result of printing input line. And here is the result of printing list1. We're close. We now have a list of strings. It's not a list of integers. What if you wanted to make that a list of integers? Well, guess what? I could do this. List2 equals, what can I do with list1 using list comprehension? Check this out. X4, Xn, list1. This is going to take every X every value out of list1, save it into X, and what do we want to do with it to make it an integer? We want to integerize it. So check this out. And now let's print list2. 7, 8, 1, 3, 9. So here is the input line. That's the result of that print statement. Here we're printing list1, and then here we are printing list2, which is now that exact same list, but everything saved as integer values. Super cool, super helpful. And guess what? We can really do that all in one go. I could have just typed numbers. I'm going to call the list numbers because that's what I'm scanning, right? Numbers equals int of x for x in, and this is going to be funky, for x in input. Check that out. And now let's print numbers. Let me just delete all of this. Let's run this code, 7, 8, 1, 2, 4. And of course, I made that mistake there. Wait. I didn't split. Input dot split. Let's do that again. What did I enter? 7, 8, 1, 2, 4. 7, 8, 1, 2, and 4. And here is the result. Are we okay with that? That's a lot. But this is something we need to practice because we're going to be using it. So we're saying we're making a list using list comprehension. We're saying get the input, split it on spaces. What's the result of that? The result is going to be a list of size 5 of all strings in this square brackets. And now we're saying loop over that list of size 5, take every individual string, because it's really a number, but string, save it into X, integerize it, the word we've made up, and now let's print out that list. This is what we get. Super helpful. All right, last thing is just to show you a problem that we are going to discuss next time. Write a program that reads in numbers separated by a space in one line and then displays distinct numbers. So if a number appears multiple times, you should only display it once. So how do you read in all the numbers into one line? The way we just showed. And so here, enter 10 numbers. Read them all and with one input. The way we just showed, using the input, splitting it, and then integerizing it using the code that we just showed here on line 6. Now we have this list of numbers. What do we want to do with that? We really want to go over that list, and for each unique number in that list, add it to a new list, and then print those distinct numbers. Chew on that a bit. We are over time. We're going to go and stop here before we get to an hour. I'll talk about this problem more next time. It's been fun. As always, reach out if you need anything. Take care, everyone.